Okay. Transcription begins with initiation. So the RNA polymerase binds to the promoter sequence, which is pretty much just the starting of the DNA, which is full of A's and T's, as you can see. And then the RNA polymerase moves along in the 5 to 3 direction on the sense strand, so the bottom one, and it separates the DNA one nucleotide at a time. And then it matches the complementary ribonucleotide to the sense strand. So one at a time, it will go along and it will move the mRNA, or the ribonucleotide. So these ones that I'm adding will form the mRNA. And as you can see, they're complementary to the sense strand of DNA. So DNA gets separated, ribonucleotide gets added. Then, once the RNA polymerase has separated the whole DNA strand and has added all the complementary ribonucleotides, it hits the terminator, which tells the RNA polymerase to pretty much stop, and it moves on to a new strand of DNA. Now, at the end of transcription, the new strand of mRNA receives a 5 cap and a poly A tail, which protect it as it leaves the nuclear membrane through a pore, as you can see here. So it leaves the nuclear membrane through a pore, and now it does the rest of its duties in the cytoplasm, and the DNA strand can go back to normal, so it just kind of doesn't have to be separated anymore. So that sucker's back to normal. Now, so translation begins. So in the 5 to 3 direction, again, a ribosome bonds to the AUG sequence at the beginning of the mRNA strand. Now, so the A site's open, it enters in there. Now, once in the P site, the corresponding anticodon, UAC, enters with its amino acid and bonds to the mRNA strand. Now the A site is open, there's nothing in there. So the next anticodon with its amino acid, lysine, enters the A site, and the ribosome moves on. So these amino acids can bond to each other, and this anticodon, once it hits the E site, is free to leave. Now the A site is open again because this is in the P site. This anticodon is in the P site. So a new anticodon with, in this case, cysteine, enters the A site, and the ribosome moves along, and these amino acids bond to this amino acid. So methionine, lysine bond with cysteine. Now as the ribosome moves along again, this anticodon hits the E site, it's released, and the A site is open again. So the final anticodon with its amino acid enter the ribosome in the A site. As the ribosome moves along, these amino acids bond to this amino acid. So now we have methionine, lysine, cysteine, and histidine. And this anticodon hits the E site, it's released. Now, once the ribosome detects, in this case it's A or UAG, so this is the termination sequence for this, it's told this is the end. My job is over. So the amino acids separate from the anticodon separates from the mRNA strand, and the ribosome moves along. It's separated, it moves along, and we are left with this sequence of amino acids. So methionine, lysine, cysteine, histidine. And this forms a polypeptide or a protein. Well, it still needs to go into its fancy shape, but it's a protein.